So this question asks us, what is the range of this graph? Remember that exponential functions have what we call asymptotic behavior. What does that mean? Sounds fancy. Well, they look like this. A times b raised to the x plus c or d, depending on which book you're looking at. But what happens is this, whatever b is, that x can be positive, it can be negative, but when it's negative, it becomes a fraction. But at some point in time, my b raised to the x approaches the value of 0, depending on whatever I plug in for x. Okay? So when that happens, this whole thing approaches 0. And then you're just left with the number c. So you usually see some sort of asymptotic behavior at y equals c when it's written in this form. So as I look at the graph, it looks like that asymptotic behavior settles in around 5, right? So what that looks like graphically is you'll see a flat line, a horizontal line somewhere on an exponential function. It could be over here, it could be down here, but at some point in time, you'll see like a flat line, okay? So remember that the range are all the possible y's. So we got to figure out what can y be. So we have the lowest value for y and the highest value for y. So it's always written like this. This is the lower boundary, and this is the upper boundary, if there's a boundary at all. Well, if I look at my function, this goes on forever in this direction. And so when you're going down in the y direction, that means that you're approaching negative infinity. It just keeps going and going and going. What is the upper boundary? What's the highest value for y that we might get close to but not actually get? Well, it looks like 5, right? This line looks like it's pretty much tapered off. It's never going to go up, it's never going to go down, so our upper boundary is 5. So this is technically the answer. Okay? Does that make sense? Any questions? Okay, good.